Right, welcome to this tutorial, and in this video we're going to look at tutorial sheet 2 of math, that is Cavendish University School of Medicine, and we're going to be solving the practical questions, that is question 15, 16, and we do 17, and we'll finish with 18 for this video. All right, let's jump into it. Right, so question 15 reads, a doctor prescribes a drug dosage according to the formula. So the formula is D is equal to 5W plus 20, where D is the dosage in milligrams and W is the patient's weight in kilograms. So now they've given us D, and we see from the formula or the equation there that that's just a linear equation, meaning there is a linear relationship here between the dosage D and or between the weight of the person and the dosage D. So how do we do this? So if a patient weighs 50 kilograms, what is the dosage? What is the dosage here? What is the dosage? Okay, so they're telling us what is the dosage. What should they take? What dosage what should they take? So we have D already there as 5W plus 20. Then we've been told that the weight, so W is for the weight, so the weight here is 50 kilograms. So the weight is 50 kilograms, so meaning what will be the dosage? So D here, I just plug in my weight, which is 50 here, then I have plus my 20, and I just get, when I multiply this here and add, I'll just get 270. And this here, this dosage is being given in milligrams. So that's what I get. Then part B says, if a patient is given 200 milligrams to 220 milligrams, what is their weight? So they've given us the dosage and they want us to calculate the weight. So D is for the dosage. So I put my 220 there, then 5W, then plus my 20 there. So what do I get? I get W. I take the 20, the other side becomes negative, subtracts there, and I remain with a 200 there. I divide by 5, and my W just becomes 40 kilograms. So the patient weighs 40 kilograms. That's for B. And for part A here, we found that the dosage that that person needs to take is 250 milligrams. Okay, next here we have this question, and it says that the concentration of a certain drug in the bloodstream decreases linearly with time. So it decreases linearly with time. And they're saying at time t equal to 0 hours, the concentration is 80 milligrams per liter. And at time 6 hours, it is 44 milligrams per liter. So they're saying find a linear equation relating concentration to what? To time. Concentration to time. So here you see our question has been given. We have an initial point or at a starting point, then also at another time. So what does this tell us? So if I was to sketch this even on a graph, I say 0, then I say my time t is there, and my concentration C is the other one. So T0, then I say, if I say 8 is here, so meaning at time 0 I have this, then I am here, then at time 6, let's say 6 is here, I'm at 44. So let's say 44 is there, like that here. Then I have this line here. So this has to be a linear straight line here. I have that line there. So to find the equation of this line, I need to find my slope, or I need to find the gradient here. So since I have these 2 points, meaning I can use the formula for the gradient, which commonly known or commonly written as m is equal to y2 minus y1 divided by x2 minus x1. But in our case here, we're looking at our gradient to be, our y is given as concentration. So you're saying concentration 2 minus concentration 1, then divided by time 2 minus time 1. So now that is going to be my concentration 2 there is 44 minus my concentration 1 is 80. Then divided by my time 1 is 6 minus uh, my time 2 is 6 minus my time 1 is 0. Then I get that this would be negative 36 divided by 6, and this just gives me negative 6. So my gradient here, I keep it here, is negative what? Negative 6. So what do I then, how do I then get my answer there? So my answer, the equation of a line that I'm going to relate is y minus y1 is equal to mx minus x1. So this then can be written as y is equal to mx minus x1 then plus y1. So now, according to how our equation has been given, then I have my x now. So in that, we are going to have time t, then here you have T1, then my Y1 was concentration, so C1 there. So I found my gradient to be negative 6, and then my T remains here. My T1 is 0, so I put my 0 there. Concentration 1 is 80, so this will be plus what? 80. To expand this, then I just get that my concentration C, even here I replace my C, I'm just going to have that this will be negative 6T, then plus the what? Plus the 80 here. So this is the linear equation that relates the concentration to time. Okay, then now they're telling us to say we must find after how many hours will the concentration reach what? Reach 20. So they've given us a concentration of 20. So I break this here. They've given us concentration of 20. Then now I have to just find my time t. So I replace 20 here. Then I have negative 6t plus 80 here. So if I bring my 6t the other side, becomes negative 60, the other side becomes positive 60, and 80 minus the 20 there, that gives me 60. So 60 over 60 divided by 6, I get t is equal to 10. So after 10 hours, all right. Next here, they are telling us to find, so a pharmacist needs to prepare 200 ml of a 10% saline solution. So I have to prepare 200 milliliters of 10% saline solution. But then it's prepared by mixing 5% solution and another 15% solution. So we prepare it by mixing 5% solution and 15% solution. So now here, what they're telling us, so let X be the amount of 5% solution used. Write a linear equation to represent the what solution. So we say let X equal to amount of 5% solution. So amount of 5% solution what used. So X is representing the amount of 5% solution used. So now, how do we then, what part is going to account for the 15% used? So if I am making 200, so 200, then subtracting that 5%, which is given now by X, meaning I'll account for the what? For the 15%. So I'm saying 200 minus the X here. This then here is just going to be equal to the what? Amount of the 15% that is used. So that accounts for the amount of the 15% that is used. But then what is my final outcome that I want to come up with? So I want to mix these two solutions, the 5% and the 15%. Then I get my 200 of the 10%. So in short, I'm saying I'm getting 10% because it says the pharmacist needs to prepare 200 ml of 10%. So the 10% can be written as 0.10. If I write that as a decimal, then divided by what? By 200 there. So this is 10% of the 200 milliliters. That is what that is there. So now, after doing this, how do I then get the other part? So the other part is saying 5% of what? So 5% of what of solution must be used. So 5% is written as, that is 0.10 5% is just written as 0.05. So 5%. So meaning 0.05 of what of my x, that was what that was used. So I'll get 0.05 of what of x that was used. Then I'm adding this because they're saying I'm using 5% plus the 15%. When I add this together, that must give me the what? The solution. So meaning the other part is what is for the 15%, and the 15% meaning I'm adding, so that is going to be 0.15. But what amount accounts for the 15% used? It is this 200 minus what? Minus x of that, of those milliliters that were used. So this here then becomes my what? My linear equation. Then if I was to expand this out, if I am to expand to just expand this, so writing 0.05x here, then distributing that okay, so let me keep it like that here. I write 0.15, then 200 here, then minus my x. On this other side, I multiply the 0.0.1. So 0.1, then I multiplied by the 200, I just get 20. So this here on this side, I get 20. So this here is my linear equation that represents the what? The situation that we have here. Okay, so that's my linear equation. Now, let me write it here. So this is 0.05x, then plus 0.15, then 200 minus x, then this is equal to 200. Then they're telling me now, solve for x and determine how much of each solution should be used. So them telling me to solve for x, in short, they're telling me to solve for that 5% solution that was what? That was used. So how do I get that that there? So to solve here, I can just expand. So if I expand, so we're now doing part B, that's 0.5x, then I expand there. So 0.15, that gives me, so 0.15 multiplied by 200, I just get 30. So this would be 30, then minus, that would be 0.15x, and that will be equal to what? To 20. So then I can add this part and that part there. So I just remain with negative 0.110x. Then the other part that remains, the 30 goes the other side. Then I just have 20 minus 30, which just gives me negative, that gives me negative 10. Then I can divide both sides by negative 0.0, negative 0.1. Then I just get that x, my x is just going to be 100 milliliters, because they're telling me how much of that solution. So meaning this accounts here for the what? Since x is 5%. So it's saying so for x, so we solved for the 5% or the amount of the 5% solution, and that is to what? 100 milliliters that was used. Then how much of the other one? So we need to find now the other one, which is what? Which is the one for the 15%, that was what that was used. So to find the amount for 15%, okay, I say this. So 15%, amount for 15% here, we're just going to get that we had said our 15% was 200. If we remove that, the x part, which is the one which we were said 5%. So we said 200 minus the x, but we found the x is just 100. So, and when we subtract this just gives us what? 100 milliliters. So this here is the other what? The other amount. So each used what? 100 100 of that solution, 100 milligrams of what? Of that solution to be in order to find this. All right, so now let us do the last question for this part. So now the question reads, a clinic orders a monthly stock of antiviral pills. The cost is made up of a fixed, not fixed, delivery fee of $150 and a cost of $3 per what? Per pill. $3 per pew, then telling us to write a linear equation for the total cost C in terms of the number of pews and the number of pews represented by the letter P. So we write a linear equation, total cost. So C is going to be equal to, so what is changing here? Saying per pew. So meaning the amount of pews are changing. So if I can want 2 pews. So meaning that would be 2 multiplied by the 3 and gives me 6. I can want 10 pews. 10 multiplied by the 3, that gives me what? That gives me 30. So meaning that my P is what is changing here. So the $3, I write my $3 here, then my P for my pews. But then I have a fixed amount. The delivery price is what is fixed. So for every amount that I would want, the delivery fee is still going to be fixed at 150 what? Yes, dollars. So this here is going to be my linear equation. Then part B tells me to find the total bill, which is 480. Then they're telling me how much pills did they order. So how much pills did they order? So now that is concentration. The concentration here is so I'm saying if the total was 480, so 480 is my cost. So I put my cost there. Then now they're telling me how many pills did they order. So I need to find what P here. So this is for B. Then that would be plus 150. Then now I saw for P. So 3P, if I take 150 the other side, I just get 480 minus 150. And this here is going to give me 3P to be equal to, I subtract this, so 480 minus the 150 gives me 330 divided by 3 both sides, and I just get my P is going to be equal to 110. So they got 110 pills. All right, if you're new to this channel, remember to hit that subscribe button, and we will see you in the next one.